Article 225.30 of the National Electrical Code requires a disconnecting means for each building or structure that contains 3 or more dwelling units. Article 230.70 requires a single disconnecting means for each service entrance. When dealing with a duplex, which has 2 dwelling units, a disconnecting means is required for each unit. Possible solutions include installing 2 separate main breaker panels, 1 panel for each unit, located on the outside of the building. Alternatively, you could install a single main breaker panel on the outside of the building and run sub-feeders to 2 separate main breaker panels inside each unit. If sub-panels are used, the sub-panel disconnects must be interlocked with the main breaker panel disconnect. The disconnect should be readily accessible and located in a visible location. Finally, the disconnect should be rated for the full ampacity of the service feeders. Let's delve deeper into the specifics of these requirements and solutions. Considering Article 225.30, it's critical to understand what constitutes a building or structure. The NEC defines a building as a structure that stands alone or is separated from adjoining structures by firewalls. This means that if the duplex units are indeed separate buildings according to this definition, each requires its own disconnecting means. Now let's break down the solutions. Firstly, installing 2 separate main breaker panels is a straightforward approach. This involves having 2 distinct panels, each serving one of the dwelling units, and each equipped with its own main breaker serving as the disconnecting means. These panels must be located in the exterior of the building to comply with code. Secondly, using a sub-panel configuration involves a single main breaker panel located outside, from which sub-feeders are run to individual panels inside each dwelling unit. In this setup, the main breaker panel acts as the primary disconnecting means for both units, while the sub-panels provide further distribution within each unit. Now, about interlocking disconnects, this refers to a mechanism that ensures that the sub-panel disconnect cannot be opened unless the main breaker is first stripped or opened. This is a safety feature designed to prevent accidental disconnection of the main power supply while someone is working on the sub-panel. In terms of accessibility and visibility, the NEC mandates that disconnects be readily accessible, meaning they should be located in a place where they can be easily reached without having to climb over obstacles or remove barriers. They should also be visible, so that anyone approaching the building can quickly identify and locate the disconnecting means in case of an emergency. Now, regarding the ampacity rating of the disconnects, this refers to the maximum amount of current that the disconnects are designed to handle. The disconnects must be rated for the full ampacity of the service feeders, meaning they must be capable of safely interrupting the flow of current in the event of a fault or overload. Now let's explore some additional considerations beyond the basic NEC requirements. Local codes and regulations may impose additional requirements or restrictions on the installation of disconnecting means. It's crucial to consult with local authorities and obtain any necessary permits before beginning any electrical work. The placement of disconnecting means should also take into account factors such as weather conditions and potential hazards. In areas prone to flooding, for example, disconnects should be located above the floodplain to prevent damage and ensure safety. Regular inspection and maintenance of disconnecting means are essential to ensure their continued reliability and safety. Disconnects should be inspected periodically for signs of corrosion, damage, or wear, and any necessary repairs or replacement should be made promptly. Now, let's address some frequently asked questions about disconnecting means. Question 1. What is the purpose of a disconnecting means? The purpose of a disconnecting means is to provide a way to safely disconnect electrical power to a building or structure in the event of an emergency, such as a fire or electrical fault. Question 2. Who is responsible for installing and maintaining disconnecting means? The responsibility for installing and maintaining disconnecting means typically falls on the property owner or manager. Question 3. What are the penalties for failing to comply with NEC requirements for disconnecting means? The penalties for failing to comply with NEC requirements for disconnecting means can vary depending on the jurisdiction, but may include fines, citations, and even criminal charges in some cases. Now, let's shift gears and discuss the importance of proper grounding and bonding in relation to disconnecting means. Grounding and bonding are essential safety measures that help to protect people and property from electrical shock and fire hazards. Grounding involves connecting electrical equipment and systems to the earth, providing a path for fault current to flow back to the source and trip the circuit breaker or fuse. Bonding involves connecting different metal parts of an electrical system together to create a low impedance path for fault current. When installing disconnecting means, it's crucial to ensure that all grounding and bonding connections are properly made and maintained. This includes grounding the disconnecting means enclosure, as well as bonding any metal conduits or raceways that enter or exit the enclosure. Now, let's talk about the different types of disconnecting means available. There are several different types of disconnecting means available, each designed for specific applications and environments. One common type is the circuit breaker, which is a device that automatically interrupts the flow of current in the event of a fault or overload. Another type is the fuse disconnect switch, which combines a disconnect switch with fuses to provide both overcurrent protection and a means of disconnecting power. Other types of disconnecting means include knife switches, pull-out switches, and manual transfer switches. The choice of which type of disconnecting means to use will depend on factors such as the voltage and current rating of the system, the environment in which it will be installed, and any applicable code requirements. Now let's delve into the specifics of selecting the right size and type of conductor for service feeders and sub-feeders. The size and type of conductor used for service feeders and sub-feeders must be selected in accordance with the NEC and any applicable local codes. The NEC provides tables that specify the minimum conductor size required for various ampacities and voltage drops. When selecting conductors, it's important to consider factors such as the ampacity of the load being served, the length of the run, the ambient temperature, and the type of insulation used on the conductor. It's also important to ensure that the conductors are properly rated for the voltage and current levels present in the system. In addition to selecting the right size and type of conductor, it's also important to install the conductors in accordance with the NEC and any applicable local codes. This includes properly supporting and securing the conductors, protecting them from physical damage, and ensuring that they are properly terminated at both ends. Now let's explore the topic of overcurrent protection in relation to disconnecting means. Overcurrent protection is a critical safety measure that helps to protect electrical systems and equipment from damage caused by excessive current flow. Overcurrent protection devices, such as circuit breakers and fuses, are designed to automatically interrupt the flow of current in the event of a fault or overload. When installing disconnecting means, it's important to ensure that the overcurrent protection devices are properly sized and coordinated with the disconnecting means. This means that the overcurrent protection devices must be capable of safely interrupting the flow of current in the event of a fault, without damaging the disconnecting means or any other components in the system. Now let's discuss the importance of proper labeling and signage for disconnecting means. Proper labeling and signage are essential for ensuring the safe and efficient operation of electrical systems. Disconnecting means should be clearly labeled with their function, voltage rating, and any other relevant information. Signage should also be provided to indicate the location of disconnecting means, as well as any potential hazards or safety precautions. In addition to labeling and signage, it's also important to provide clear and concise instructions for operating the disconnecting means. This may include instructions on how to turn the disconnecting means on and off, as well as any safety precautions that should be taken when operating the disconnecting means. Now let's turn our attention to the topic of surge protection in relation to disconnecting means. Surge protection is a critical safety measure that helps to protect electrical equipment and systems from damage caused by voltage surges. Voltage surges can be caused by a variety of factors, including lightning strikes, power grid switching, and equipment malfunctions. Surge protection devices, such as surge suppressors, are designed to divert excess voltage away from sensitive equipment and prevent damage. When installing disconnecting means, it's important to consider the need for surge protection, especially in areas that are prone to lightning strikes or other sources of voltage surges. Surge protection devices can be installed at the main service entrance, as well as at individual branch circuits to provide comprehensive protection for the entire electrical system. Now let's discuss the importance of arc flash hazard analysis in relation to disconnecting means. Arc flash is a dangerous phenomenon that can occur when electrical equipment is energized. An arc flash is a type of electrical explosion that can generate intense heat, pressure, and light, posing a serious risk of injury or death to workers. Arc flash hazard analysis is a process of evaluating the potential arc flash hazards in an electrical system and determining the appropriate safety measures to mitigate those hazards. When installing disconnecting means, it's important to conduct an arc flash hazard analysis to determine the potential arc flash hazards and ensure that the disconnecting means are properly designed and installed to minimize those hazards. This may include using arc-resistant equipment, providing adequate working clearances, and implementing lockout-tagout procedures. Now let's explore the topic of energy efficiency in relation to disconnecting means. Energy efficiency is an increasingly important consideration in the design and operation of electrical systems. Disconnecting means can play a role in energy efficiency by allowing users to easily disconnect power to equipment and systems that are not in use, reducing energy consumption and saving money. For example, disconnecting means can be used to disconnect power to lighting systems, HVAC systems, and other equipment when they are not needed, such as during off hours or in unoccupied spaces. In addition to using disconnecting means to reduce energy consumption, it's also important to select energy-efficient disconnecting means. This may include using disconnecting means that have low resistance connections and minimal energy losses. Now let's discuss the importance of proper documentation and record keeping for disconnecting means. Proper documentation and record keeping are essential for ensuring the safe and efficient operation of electrical systems. Documentation should include detailed drawings and specifications for the disconnecting means, as well as records of all inspections, tests, and maintenance activities. Records should also be kept of any modifications or repairs that are made to the disconnecting means. In addition to documentation and record keeping, it's also important to provide training to workers on the proper operation and maintenance of disconnecting means. Training should cover topics such as the function of the disconnecting means, how to operate it safely, and what to do in the event of an emergency. Now let's shift gears and discuss some of the common mistakes that are made when installing disconnecting means. One common mistake is failing to properly size the disconnecting means for the load being served. Another common mistake is failing to properly ground and bond the disconnecting means. Other common mistakes include failing to provide adequate working clearances, failing to properly label and sign the disconnecting means, and failing to conduct an arc flash hazard analysis. By avoiding these common mistakes, you can help to ensure the safe and efficient operation of electrical systems. Now let's explore some of the emerging trends in disconnecting means technology. One emerging trend is the development of smart disconnecting means that can be controlled remotely and monitored for performance. Another emerging trend is the use of solid-state disconnecting means, which offer improved reliability and performance compared to traditional mechanical disconnecting means. Other emerging trends include the development of arc-resistant disconnecting means and the use of wireless communication technologies for monitoring and controlling disconnecting means. As technology continues to advance, we can expect to see even more innovative developments in disconnecting means technology in the years to come. Now let's discuss the importance of staying up to date on the latest NEC requirements for disconnecting means. The NEC is a constantly evolving document that is updated every 3 years to reflect the latest advancements in technology and safety practices. It's important to stay up to date on the latest NEC requirements for disconnecting means to ensure that electrical systems are designed, installed, and maintained in accordance with the most current standards. This may involve attending training courses, reading industry publications, and consulting with qualified electrical professionals. By staying up to date on the latest NEC requirements, you can help to ensure the safety and reliability of electrical systems. Now let's conclude by summarizing the key points that we have discussed in this video. We have discussed the importance of disconnecting means for ensuring the safety and reliability of electrical systems. We have explored the NEC requirements for disconnecting means, as well as the different types of disconnecting means available. We have also discussed the importance of proper grounding and bonding, overcurrent protection, labeling and signage, surge protection, arc flash hazard analysis, energy efficiency, and documentation and record keeping. By following the guidelines and recommendations that we have discussed in this video, you can help to ensure the safe and efficient operation of electrical systems.